So I'm going to show you a couple more. I think this might be the last proof. I'm going to show you a couple more proofs, and then I'm going to give you some assignment to work on where you can practice some of these things. I think I'm also going to show you, no, I might do that Wednesday. Same old process again and again. Cut off the no, which is the piece between the if and the then. I'm given that D is the greatest common divisor of A and B. And I wrote it down, and then I expanded. So I write down the definition. Now, one thing that bothers me about Underwood-Dudley is he doesn't write down all the details. I would write down if A is, let A be a positive integer. B. So he means all that when he writes the statement, but he hasn't written it, and that's really not cool. And this part here can be expanded further, right? Why am I doing that? Now that you've watched me do a couple proofs like this, why would I keep blowing this up? Why did I do this part right here? How's that going to be helpful? Say it again? Oh, that's not, we're not there all the way there yet. Eventually we'll get there. What am I looking for when I'm trying to put together these puzzles? Something to work with. I got my equations. I got something I can get my hands onto. I call them nuggets. I got a nugget. I got a puzzle piece. I can work with this. So that's why I'm doing that. And if you blow past that and don't do that piece, then you have nothing to work with. So you're trying to like have a lightning bolt strike you and just come up with a proof. That's really hard. So now I rewrote the statement so that you could follow along in the lecture, but I just took the show part, which is that 1 is the greatest common divisor of A divided by B, the fraction A divided by B, which turns out to be an integer because D divides A, right? And B divided by D is going to be 1. So that's what I'm supposed to show. And that's kind of hard to expand because 1 divides everything. So this is a trick. If you have a 1 that you're dealing with, you can put 1 divides, but 1 divides everything. So the common divisor piece is useless. And the second part is kind of useless too, because you get, if anything's another divisor, then it has to be less or equal to 1. It doesn't give you any more information to play with. So the trick is to introduce another letter. Let C be this greatest common divisor and show C as 1. That gives you some equations to head towards. And another thing is that you can use this as no now, because as soon as I say assume or let, I can use that in my no. And so I can expand that out. C equals that common divisor, greatest common divisor means C divides A divided by D, and C divides B divided by D, and it's great as such. If I expand it further, I get A divided by D is C times X, and B divided by D, the same old definitions again. But again, realize that these two nuggets, now I can use them. They're in my assume, right? And my job now has been reduced to show C is equal to 1. So that's my usual no. I write a lot of scrap. I feel like the one thing I ask for in this College of Science and Math is paper and pencil. I don't have a lab. I don't need lab assistants. I don't need all kinds of expensive equipment. Just give me paper and pencil. So I'm okay with taking a big scratch paper box and writing all over the place. So I take that and I write down my usable no in an organized way so I can see it, not hidden away in my scratch work. My job is to show C is 1. Now my job is very clear, and I have it all set up. So I'm just messing around. Really, it's free play. And one of the times I taught combinatorics, I realized students are really uncomfortable with free play. You gotta be okay with that. Play around with stuff, it's okay. So I'm gonna mess around with things. I labeled all these little equations that I can use, 1, 2, 3, 4, and just started messing it around. 3, if I substitute, can be rephrased as, or I just cross multiply, I can get rid of that denominator. So I have A is equal to C times D times X. And you don't have to, this is just high school algebra. So I just mess around and I come up with the conclusion that A is dx. I think that this is what I wanted. S is cx. So I'm relating the equations to each other. And from this, I always mess around. I have no purpose with it. And then I look at what I got. So what do I got here? I got that CD and CD divides both B and A. The product CD. Then I just stare at it for a while and say, what can I say from all this messing around? Can I come up with some conclusion from it? And the conclusion is CD divides both A and B. All right, let me see if that helps me in any way. So it's a common divisor of A and B. But it can't be bigger than the greatest common divisor, right? Because that's the definition of the greatest common divisor, it's the biggest one. So that tells me that CD has to be smaller than or equal to D. Well, that means C is less or equal to 1. And I'm done, because C is a positive integer. It's almost like an accident. I just played around with it, messed around with it, and like, wow, it ended up right. By the way, that's going to be true for your undergraduate classes. It's not true. If you're going on to graduate school, they'll give you theorems to prove that aren't even true. And so you're messing around with it, and you're like, God, this must be true because it was in the book, and it's not even true. And then the professor will laugh and say, ha, it wasn't even true. Or you have a list of 10 things that say, prove or find a counterexample to the following. So you don't know if they're true or false. So at least right now, you're in a good place where everything in the book is something that you mess around with and you should be able to get to. That messing around period can take a while when you're at the beginning stages. Now, in the hypothesis, I used the fact that this is the greatest common divisor. There's two parts of greatest common divisor. One is that it's a common divisor, and then the second is that it's greatest. The second part is harder to use because you can't really get your hands on it. It's an inequality, it's not an equality, it's not an equation. And if you don't use something from the hypothesis, be worried. So if they say, the function's continuous, prove blah, 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 and I never used that continuity property anywhere, be worried, something's left out. At least for undergraduate classes, something's wrong. So I had to use the fact this was the greatest common divisor, the biggest of them all, to get my end result. And I was actually starting to think around this time, like, I didn't think I used that property yet. And there it came. It was there. Like, whew, I used it. So that finishes it. Questions?